You know, have you ever stopped to think about the invisible forces happening inside the machines we use all the time? I'm talking about these tiny, unseen shakes and shudders. They're secretly just eating up energy and wrecking performance. Well, today, we're going to pull back the curtain on this hidden world and see exactly how engineers are taming that shake in the system.
All right, so here's a fun one for you. What in the world does a little desktop 3D printer, the kind that meticulously builds things layer by layer, have in common with a giant, heavy-duty industrial conveyor belt? I mean, they seem like total opposites, right? Well, believe it or not, the answer is this surprisingly common and really pesky engineering problem, a hidden vibration that engineers are working super hard to solve.
And that leads us right into our first section. We're talking about the unseen shake. The first challenge is just identifying it. And we're going to start with something you've probably seen a million times without a second thought, a simple dry belt. Turns out this is exactly where the problem is often hiding, right in plain sight.
Okay, so at the very heart of this whole thing is a concept called harmful vibration. And it's exactly what it sounds like. Just imagine a machine's energy getting completely sidetracked. Instead of all that power going into doing its actual job, it gets wasted on this useless and sometimes even destructive shaking. These unwanted oscillations, they just kill the machine's performance.
And this really just lays it all out, doesn't it? It's like the two sides of the story. On one side, you've got the goal, a system that's just smooth, it's efficient, it's doing what it's supposed to do. But then you look at the other side, and that's the problem, a vibrating system. It's chaotic, it's wasting energy, it's underperforming. And really, the entire goal of all this engineering work is to take that shaky mess on the right and turn it into that smooth operator on the left.
All right, so if we know the vibration is the problem, well, the next logical question is, where is it coming from? What's actually causing it? So let's dive into that investigation phase and see how we can uncover the root causes of this shake.
So when engineers really dig in, they find a few usual suspects. It can be something as simple as the pulleys not lining up perfectly, That forces the belt to wobble. Or maybe the rollers themselves are vibrating, or they're not anchored down properly. Even the angle of the conveyor belt can cause issues. The crazy thing is, each one of these seemingly small flaws can introduce that huge, harmful shake into the whole system.
Now, all of those things can definitely play a part, but research points to one main suspect time and time again, and it's a really common one: pulley misalignment. It's simple, really. When the wheels that guide the belt aren't lined up just right, it creates this constant wobble, and that wobble just travels through the entire belt drive, causing all kinds of headaches. Okay, this is where it gets super interesting. I mean, how do you even fight an enemy you can't see? You have to find a way to make it visible. So in this next part, we're going to look at how engineers literally listen to the machine, how they diagnose these invisible vibrations with honestly incredible precision. And it all comes down to having the right toolkit. Engineers use these super sensitive devices called accelerometers to, well, feel the shake. They've also got laser speed sensors to see these tiny, tiny fluctuations in the belt's speed. Then they take all that raw data, all those numbers, and use some pretty sophisticated analysis to turn it into a clear picture of what's actually going wrong. And the process itself is very methodical, very scientific. First things first, they attach all these high-tech sensors to the system. Step 2, they run the machine, usually under a bunch of different conditions. And finally, they crunch the numbers. They analyze all that vibration data to pinpoint the exact source and nature of the problem.
All right, so we've found the problem, we've measured it. Now what? Well, this is the exciting part. Let's get into how we engineer a solution. It's all about creating a much quieter, smoother ride for the machine.
And the hero of our story? Well, it has a name. It's called damping. That's the official engineering term for actively fighting back against those unwanted shakes. Damping is all about designing systems that can either absorb or cancel out vibrations, basically calming the entire machine right down. And here's the crucial thing. This isn't just about, slopping a piece of rubber on it and hoping for the best. Nope. The real solution comes from deeply understanding the physics behind it. Engineers actually create these super detailed mathematical models of the vibration so they can design damping systems that are precisely tuned to fight the specific shake they're dealing with. So I know this all might sound super technical, but trust me, it has huge real-world consequences. Let's connect the dots here and see why taming these tiny little vibrations matters so much, from the gadget on your desktop all the way to the factory floor.
Yeah, and this chart really spells out the cost of just ignoring the problem. See, unchecked vibration isn't just some minor annoyance. It leads to major energy loss, and that costs real money. It absolutely tanks the machine's performance. And all that constant shaking, it literally wears the parts out faster, which can dramatically shorten a machine's lifespan.
But here's the good news. When you get it right, the payoff is huge. You implement effective damping, and you basically just reverse all those negatives. Performance goes way up, you stop wasting all that energy. So for a 3D printer, what does that mean? It means much higher quality prints. For a conveyor belt, a way more efficient system. And for both of them, it means a longer, more productive life. It's a win-win-win.
And this quote really just hits the nail on the head. At the end of the day, this isn't some abstract physics problem for a textbook. The focus is crystal clear and it's practical. Reduce energy losses and improve operational performance. Plain and simple, make things work better and stop wasting energy.
So if there's one thing to take away from all this, it's this. These tiny, completely unseen forces, these little shakes and vibrations, they have a massive impact on the technology we rely on every single day. From that 3D printer on a desk to the giant systems that power our entire industries.
It really makes you wonder, doesn't it? If engineers are out there battling these invisible vibrations, what other unseen forces are they fighting every day just to make our world run a little bit smoother, a little bit better? Something to think about.